Welcome to today's presentation where we will be configuring Access Client Solutions, or ACS, to use SSL or TLS. My name is Amy Williams. I'm a Senior Security Services Consultant with Help Systems, and my primary focus is on the IBMI. What we'll be covering today is why to encrypt your sessions, what SSL and TLS are, how to configure the Digital Certificate Manager, and configuring Access Client Solutions to request that encrypted session. Why should you encrypt your sessions? For many businesses, depending on your location and type of transactions, there are local laws and regulations requiring data be encrypted in flight. A few examples of these are the Payment Card Data Industry Standards, or PCI, GDPR, HIPAA, and CCPA, just to name a few. Data should not be in clear text, even when flowing through your own internal network. When an organization is compromised, one of the things that bad actors will often do is leave behind sniffers on your network. And using these, they can obtain user IDs and passwords being passed in the clear, as well as sensitive application data. So the next time you're logging in and keying in that tremendously complex password, think about who might be admiring your effort. So how do we go about fixing this? Let's discuss encrypting the communications. Establishing an encrypted session begins with the client making a request for an encrypted session with the server. When using a web browser, it is the browser requesting that encrypted session with the web server. After the client is configured to require secure communication, it contacts the server, says, "Hey server, I want to get an encrypted session, and here are all the different languages that I can speak." And when we talk about languages, in this case, this is the list of ciphers or the encryption algorithms that can be used to encrypt that session. Then the server responds back to the client, and one of the things that it sends back is that digital certificate. Next, the client determines if it actually trusts who issued that digital certificate. And if it does trust it, the client generates a session key, and the rest of the session is then encrypted using a symmetric key. And using a symmetric key means that the session is going to be fast. A digital certificate plays a huge part in this encryption process. It allows the client to trust the server based on who issues it, and it also facilitates that encrypted session. A digital certificate issued by a certificate authority often is referred to as simply a CA. There are three main types of CAs. A well-known CA, this is an organization like VeriSign or DigiCert. You can go to their website and you can get a one-off certificate, or you can contract with them to get all of your certificates. These organizations are referred to as well-known CAs. There are also internal CAs, where your organization may have its own internal certificate authority that issues certificates. Additionally, we can make the IBMI be a certificate authority. And we'll see later how we can configure that so that IBMI can issue its own digital certificates. Regardless of who issued it, a digital certificate always has the validity period. And there are two of these that you need to pay attention to. First is the validity period of the certificate authority itself, and then there's the validity period of the digital certificate. Most recently, this has been designated that the certificates can only be issued in 1 year validity periods. No longer can you configure those to be longer. If either of those are expired, then the digital certificate is no longer good, and a secure communication connection cannot be established. The next thing that digital certificate can do is it's going to determine the strength of that encrypted communication by what protocol and what algorithm can be used. Like most things, algorithms and the protocols have evolved over time. We often refer to all of this as SSL, even though today SSL has been deprecated and TLS is what's really in place. SSL stands for Secure Sockets Layer, and after version 3, it evolved into the Transport Layer Security. TLS 1.0 was essentially the same as SSL v3, and both of those had huge vulnerabilities in them. TLS 1.1 was released 7 years after TLS 1.0, and that has also now been deprecated. TLS 1.2 was established in 2008, and then 10 years later, TLS 1.3, which is generally the most accepted protocol. There are 3 system values on the IBMI that will assist you when you're configuring TLS on the IBMI. The first one is the QSSL PCL. This is the protocol list. This determines which protocols are available for secure connections on your system. These are not in any priority order. It's simply a list of those that are available. We, again, recommend using TLS 1.3 and TLS 1.2 only when necessary. All other protocols have been deprecated. If we look at it by OS release, you can see the newer releases don't even allow SSL to be configured. TLS 1.0 is the oldest protocol, and again, 1.0 and 1.1 have been deprecated. So what cipher suites or algorithms are actually available? Again, that's going to be based on the protocol. The newer TLS is going to enable you to use the strongest encryption algorithms available. Like the protocols, the available cipher suites or algorithms depends on the version of the operating system that you're running. These lists of ciphers is controlled by the QSSL CSL system value and is an ordered list. However, you can control the order that these ciphers are selected by using the QSSL CSL CTL system value and setting it to user defined. When you go to configure Access Client Solutions, you can't just configure Access Client Solutions to request a secure communication with the server and expect it to work. The server also must be configured to allow for those secure communications. So let's get to configuring the IBMI server. The Digital Certificate Manager, DCM, is the way that we'll be able to make these configurations. This is where we take that digital certificate and we're going to assign it to the servers that we want to have the ability to encrypt their communications. In this, we're going to talk about applications, which are really TCP servers like Telnet, FTP, or the database server. When you sign into DCM, you're going to notice these servers now being called applications. Once you've assigned the certificate, it will default to a specific protocol and set of cipher suites. You can refine that in DCM if you wish to eliminate some of the weaker ciphers or weaker protocols. To access DCM, open a browser, use your system name or IP address, followed by a colon, port 2006/DCM, and this will bring you to the sign-on screen, allowing you to access the DCM. After you've logged into DCM, you'll want to either create a certificate store or open an existing system store. Today I'm going to walk you through creating that system certificate store. So we'll click on Create Certificate Store. We'll be presented a list of eligible stores to be created. We'll click on System. And at this point, we'll be prompted to enter a password and click Create to actually establish that certificate store. When doing this, you will need to be logged in as a user profile with all object and SecAdmin authority at a minimum. Once the system store is created, we're going to select the system store and we're going to create a certificate. When we click Create, we're going to be presented with a question if we want an Internet CA or a local CA if the local CA store is already established. In this instance, we're going to request an Internet CA, and with that, we're going to create a CSR or a certificate request. You'll fill out this form with the label you want your certificate to have, the key algorithm that you want to use. The common name is what will remain with your certificate going forward. And then your organization information, location, and country. You will then be presented with the certificate request. This text must be copied from beginning to end, from the very first dash to the very last dash. And in the new DCM UI, IBM's made this very convenient for us, and all you need to do is click that copy, and it grabs that entire text string. You're then going to take that and send it to your certificate authority. As mentioned, VeriSign or DigiCert or whomever is your issuing authority. They will return to you a certificate that you'll then be able to import into your certificate store. You're going to save that on your PC, and we're going to upload it into the IFS. So once you've uploaded that certificate into the IFS, you're going to go back to DCM. You're going to select your system store. You're going to click on Import Certificate, select Server or Client Certificate. You're then going to key in the path of the certificate that you just saved to the IFS. You're going to have to provide the password that the CA gave you. And at that point, you'll be able to click Import and should receive an import certificate succeeded. Now that you have a certificate that's successfully signed and in your certificate store, we can start assigning it to servers or applications. So within the system store, at the bottom, you will see a plus sign, and that'll open up a submenu. So from there, you can do a renew, an export, you can delete the certificate, validate the certificate that the dates are still good, and assign that certificate to applications. And that's what we're going to do. So by clicking the Assign button, it's going to bring up a list of upwards of 20 different applications. Today we're going to focus on the server applications so that we can secure ACS. Once you've selected all those, you'll click the Replace. That'll assign the certificate to those servers, and you will receive an informational window pop up showing all the different servers that you've assigned that certificate to. So now that we have that certificate, let's walk through having IBM I actually be your certificate authority. So there's no sending anything out to anyone. There's no waiting for a response back. It's all going to be on the IBM I. So the first thing you'll do, if you don't have the local CA store created, you'll create the local CA store and set a password. Next, we'll be able to create a new certificate. So when we go to our system store, we'll be able to select our local CA. So when in the local CA store, select Create, and again, you're going to complete this form depending on what protocols and algorithms you want this certificate to be eligible for. You'll fill out your business information, you'll click Create, and you'll receive that confirmation message that the certificate's been created. Now we'll create a certificate that'll be signed by that local CA. So open your system store, click Create a Certificate, and now local CA should be an option. Select local CA, complete the information similar to as you did before, and your local cert will be created. Now we can actually add that certificate to our servers and have both assigned at the same time. Again, select your servers, click Add this time, and you'll get the confirmation message that the certificate's been assigned to all of those applications or servers. So how do we configure a web application to use secure certificates? There's an extra step to be able to do this in creating the application to be available to the DCM. To be able to do the web server, it's going to have to be available in DCM. So if you open the system store, click on Manage Application Definitions, if that web application isn't listed, you're going to have to create it. Let's walk through how you would go about doing that. As an example, we'll be using one of our help systems applications, Policy Minders Web UI. So you would go to the web application configuration, you would enable it for SSL. You can either name the application or you can just take the default server application ID that IBM provides you, set the port that you want to be used, and then click Apply, and then OK. Now, when we go back into the system store, that web application will be available under our Manage Applications, and we can assign the certificate just as we did with the other applications. So now we have our certificates assigned, our servers are ready. How do we configure ACS to actually request that encrypted session? So within ACS, you're going to modify your system configuration. So by clicking on System Configurations, choosing the system that you want to modify, and then editing. On the General tab, by selecting Use SSL for Connection, this will default all the connections using that system definition to use secure communications. So this will be your ODBC, your Telnet, the transfer facilities, either upload or download through ACS. With ACS, it will automatically detect that certificate of authority is associated with the certificate on the server. You can choose either to trust that certificate of authority or not to trust the certificate of authority. If you click yes, it will add that CA to the client key store that resides on the PC. If you click no, then you will not be able to successfully connect to the system securely. You can also default new configurations to use SSL, and to do this, you'll want to go into Preferences and then Default Communications to SSL. So to verify that Telnet is secure, when you make that connection, you should see a lock in the bottom of the session. When you configure only Telnet, you can go just to your session and select the protocol to be Telnet TLS and reconnect. And then another way that you can verify that's a secure connection and see what protocols and algorithms are being used. From that session, you can go to Communications and Security, and it'll actually show you the name of the certificate being used and the algorithm that's been assigned. And lastly, when you're in using Run SQL Scripts, which is an ODBC connection, you can see that the job name will no longer be QZDASO for open and net, but it will be QZDASS for secure and net. And now you are not communicating or transferring any data or any commands over clear text. So some additional resources, getting started with DCM, and some good facts about DCM. There have been quite a few changes with the new PTFs that have been released for 7.3 and 7.4, and now with 7.5. So it's good to keep up on what those changes are and what they might mean for managing your certificates and your different servers. At Help Systems, we do have solution-based offerings. So security, vulnerability management, compliance, virus protection and ransomware, secure managed file transfer. So when you're thinking about improving your posture and securing your communications, reach out. Is likely that we can help you in whatever area you're trying to improve. Now, along with the solutions, we do have professional security services. So we have managed security services, which is a monthly service, helping you monitor and ensure that your systems are staying configured securely. We have risk assessments that are more of a deep dive, best practices evaluation of your system configurations. And additionally, we have penetration testing on the IBMI, remediation services. So if you need assistance with any of these improvements you want to make, we can assist you there. Simply putting a plan together for you and working with you on what your next steps are using our architecture services. And then adding that next level of security and actually eliminating the passwords completely is our single sign-on services. And if you're not sure where to get started, starting with a security review and using our free security scan is always a great place to start. This will give you a lot of information about your system and also includes 1 hour with one of our security experts to go over the results from your system. I'd like to thank you again for joining us today. And if you have any questions, email us at info@helpsystems.com.